Hello everyone, and welcome to part 2 of the solutions lecture for the Decision Trees and Random Forest project. Let's go ahead and jump back to the notebook where we left off last time. Okay, here I am back at the notebook. Last time we finished the exploratory data analysis with some visualizations, and we're going to go ahead and move on to setting up the data. If you go ahead and check out the loans.info again, you'll notice that we have a categorical column we have to deal with, and that was the purpose column that we previously plotted out with this visualization here. Let's go ahead and use pd.getDummies in order to transform that into some dummy variables. I'm going to show you how you can do this with pd.getDummies and pandas. First thing we're going to do is create a list of one element containing the string purpose, and we're going to call that cat_feats. And the reason we're doing it this way is just to show you how you could basically expand this to multiple categorical columns. Now go ahead and use pd.getDummies, loans, columns equals cat_feats, and drop_first equals true to create a fixed larger data frame that has new feature columns with dummy variables. And we'll set this equal to final data. Let's go ahead and see that. We'll say final_data is equal to pd.getDummies, and then we're going to pass in loans as our data frame. We'll say the columns we want to convert to dummy variables is cat_feats, and that's going to be the list of columns. Let me go ahead and make sure this ran. So we have cat_feats here, and then we're going to say drop first equals true to avoid any multi-collinearity issues. Run that, and now we have our final data. Let's go ahead and take a look at it. With info, and now you'll notice that we have several purpose columns: credit card, debt consolidation, educational, home improvement. And if we go ahead and check out the head of the data frame, and we scroll all the way to the right, we'll notice we basically have a bunch of zeros and ones here for each of those purposes. That's exactly what we want. Now we can go ahead and train test split this data. I'm going to use from sklearn.cross-validation import train test split, and then call train test split, shift tab so I can see the documentation here, scroll down, and copy and paste this line to save myself some typing. And then I'm going to go ahead and set test size to 0.3 and random state to 101 so your results can match mine if you want to follow along. And we need to specify what x is equal to and what y is equal to. Y is just what we're trying to predict, and in this case it is the not fully paid column. So not.fully.paid, and x is everything else. So that's final data, and we just drop the not fully paid column along x is equal to 1 since it's a column. Let's go ahead and run this, make sure it works. Great. Now we can go ahead and train a decision tree model. So we're going to train a decision tree, just a single one. So we can say from sklearn.tree import decision tree classifier. And we're going to go ahead and create an instance of a decision tree classifier. So we'll say dtree is equal to decision tree classifier, and I can just use tab to help myself autocomplete some of this. And then I'm going to fit this to the data. So dtree fit on the x train and the y train data. Perfect. And now let's go ahead and get some predictions and evaluate our decision tree. So I can create predictions, as always, just by calling the predict method and then passing in the test features. In this case, that's x_test. And then I want to go ahead and maybe make a confusion matrix and a classification report. So I'll say from sklearn.metrics import classification report and then a confusion matrix. I'll go ahead and print out my classification report. I'm just using tab here with ytest and my predictions. Let's go ahead and run this. And it looks like we have precision recall around 75-ish%, hovering around there. We can go ahead and check out the confusion matrix as well. So confusion matrix, ytest, and then predictions. And don't worry if your results didn't match exactly what the output was. It kind of depends on how the random splits happened for the train test split. And later on for your random forest model, that will also take into account as far as the actual random splits of the trees themselves. All right, so we have classification reporting that we have around 74-75% precision recall, depending on what topics or what classes we're actually looking at, 0 versus 1. Let's go ahead and turn to a random forest model to compare this to. We'll go ahead and create an instance of a random forest classifier class and fit it to our training data from the previous step. So random forest is from the ensemble family because it's an ensemble of decision trees. We're going to say import random forest classifier, RFC, and then go ahead and tab autocomplete that. And we can select a number of estimators. Go ahead and select maybe something around 300 since our data is quite large, but again, this is something you can play around with. At a certain point, the number of estimators increasing won't help you anymore. You'll just kind of hover around a particular accuracy score. But a low number can be improved. We'll go ahead and say rfc.fit, and then we'll go ahead and fit this to our xtrain and ytrain values. And this may take some time. It takes longer if you have more estimators, so keep that in mind. Now let's go ahead and get some predictions and evaluate our random forest model. I'm going to go ahead and say predictions is equal to rfc.predict off of xtest. Go ahead and run that. And then we'll create a classification report from the results. And I can actually just copy and paste this from this line, since we're also calling predictions here. We overwrote predictions. So I'm going to go ahead and run that and see what we get. Okay, now let's go ahead and check out the confusion matrix. By essentially running the exact same line, but instead of classification report, we will get confusion matrix, just with a tab autocomplete there. All right, so notice now the precision recall and F1 score for certain classes has improved, and overall on average divided by total it's improved, but the recall, for instance, for class 1, here it's 0.02, and if you go back to the single decision tree, it's 0.23. So the question now is, what performed better, the random forest or the decision tree? Well, it really depends on what metric you're trying to optimize for. And I really want you to notice here the recall for each class for the models. Neither did very well, but the single decision tree did better on class 1 for recall than our random forest here, which only got 0.02. And likewise for F1 score, we only got 0.04 for class 1 versus 0.22 for class 1 on the decision tree. So it really depends on what the cost associated with each of these calls is. Overall, if you average it, the random forest model did better, but if you look at particular spots, it did much worse. So it really depends on your data, and that's the kind of thing where you'll need your business domain experience, that third circle of that Venn diagram, to actually understand what's the best model here. All right. You may go ahead and explore this further by trying to engineer some more features to try to help your precision and recall values for certain classes. All right. Hope you enjoyed this lecture and the solutions. Thanks. I'll see you at the next one.